Welcome to the Advanced Flows for AMD Versal Devices Tech Module. Here is the agenda for this Tech Module. We will focus on why the Advanced Flow is needed, introducing the Advanced Flow in the Vivado Design Suite, reviewing the new place and route architecture and algorithms, using the new placer directives, options, and strategies, using the Advanced Flow in Vivado. AMD Versal Adaptive SoCs combine powerful programmable logic with acceleration engines and advanced memory and interfacing technologies, enabling customized and efficient heterogeneous acceleration for various applications. Versal devices feature significantly increased logic density, resulting in enhanced performance and greater capacity. The table here compares the VU19P from the UltraScale Plus family with the VP1902 from the Versal Premium series, which is a large device. The transition from UltraScale Plus to Versal devices has resulted in significant increase in key resources. The number of CLB LUTs, block RAMs, URAM, DSPs, and logic cells has doubled. This enhancement allows for more complex designs. However, with this increased complexity, compile times have risen in a nonlinear manner. These advancements have necessitated innovations in the Vivado tools to effectively manage compile time, design closure, and congestion as designs become more complex. To address the challenge of longer compile times with the Versal architecture, optimizing and accelerating the place and route process is crucial. Enhancing this step will help manage the complexity of Versal adaptive SoCs. Starting with the 2024.2 release, the Vivado Design Suite introduces the Advanced Flow for all Versal devices. This new flow features new place and route algorithms for faster design performance, improved routability, and better ability to solve complex clock placement requirements. Additional architectural improvements enhance the ability to break large complex problems into smaller ones that can be solved in parallel. The introduction of the Advanced Flow delivers a significant speed up in compile times, improving your overall productivity with more turns per day. In the following sections, we will explore the advantages of Advanced Flow in further detail. In the 2024.2 release of the Vivado Design Suite, the Advanced Flow is automatically enabled for all Versal devices. Since the Advanced Flow is contained within the Vivado back-end place and route, there is no change to the Vivado front-end design processes. IP integrator, IP customization, and RTL development are the same with Advanced Flow. Note that Advanced Flow does not support previous Generation 7 series, UltraScale, and UltraScale Plus devices. Considering that Advanced Flow is integrated into the familiar Vivado IDE, there is no need to learn a new design environment. Advanced Flow offers all the capabilities of the Vivado IDE for assembling, implementing, and validating designs and IP. Project and non-project flows and related tcl remain largely unchanged. This Advanced Flow in AMD Vivado 2024.2 is an enhanced compilation tool featuring new implementation algorithms designed to boost design productivity and mainly reduce compile times for larger, more complex, and feature-rich AMD Versal adaptive SoCs. After taking several example designs targeting Versal monolithic and SSIT devices into consideration and running them with Vivado 2024.1 with standard flow and Vivado 2024.2 with advanced flow, we observed that the advanced flow directly addresses the key challenge of compile time and gives the compile time speed up of 2x in case of the Versal SSIT devices and 1.7x in terms of Versal monolithic devices. And with respect to the performance calculated using the worst-case negative slack, WNS, of the clocks in the design, it provides average performance improvement of 4.7% in case of the Versal SSIT devices and 4.5% in terms of Versal monolithic devices. Now let's take a deeper dive into the components of the advanced flow that make it a much more capable solution for AMD Versal devices. Key features include automatic partitioning to divide large complex designs into smaller place and route problems that can be solved in parallel, along with new place and route infrastructure to more efficiently handle parallel compilation of the partitions. Inside AMD Vivado 2024.1, Advanced Flow uses much leaner data structures for storage and retrieval of physical design info, which not only improves place and route speed, but also reading and writing of large designs using checkpoints and memory footprint. Improvements in multi-threading further enhance place and route efficiency. Now let's take a closer look at the improvements within the placer and router. A new timing engine that is optimized to work with the placer and its data structures helps quickly evaluate the timing impact of placement changes. Additionally, the placer adds capability to reduce routing congestion per direction, which significantly improves overall design routability. The capacity of the new clock region placer is greatly increased, resulting in better handling of complex designs with large numbers of global clocks. The router can take the partitioning info from the placer and route those partitions in parallel, but can also predict ahead of time how many partitions to use. After initial routing, different combinations of parameters and thresholds for routing algorithms are explored automatically. The best combinations are chosen, steering the algorithms to quickly converge on timing requirements. Overall, the advanced flow improvements uncover significantly more solution space in a shorter amount of time, helping you become more productive with more turns per day. Let's talk more about the automatic partition flow. The design flow begins with automatic partitioning and floor planning. For SSI devices, this involves partitioning logic into superlogic regions, or SLRs, and for monolithic devices, partitioning logic into different regions within the device. This partitioning is done by the automatic partitioner in the placer. The partitioner analyzes the design hierarchy, resource usage, and connections between hierarchical blocks. Once partitioned, the design is then placed in parallel, starting with the global placer phase, which optimizes design placement across the entire device with course-level timing and congestion optimization. Finally, the detailed placer and post-place optimizer refine the placement to ensure optimal pin density and best overall performance. The partitioning info is then passed to the router, where it uses the same partitions and routes them in parallel, enabling very fast timing convergence. As in prior versions, physical optimization, the PhysOpt design step, can be used anytime after placement to improve timing. This new tool architecture features the automated breakdown of large, complex designs into separate partitions, enabling faster compile times without user intervention. As we discussed earlier, the overall design flow does not change with the introduction of the advanced flow. However, there is a notable difference in placer directives. Unlike prior AMD Vivado tool versions, which included many placer directives, the advanced flow has simplified the list to 5 basic directives shown in the table: Quick, Runtime Optimized, Default, and Explore as before, and a new one, Aggressive Explore. These directives provide different modes of behavior for the place design command and affect all placer phases. The advanced flow uses the same option and syntax for directives. For example, place design-directive aggressive explore runs the placer with the highest effort towards meeting timing constraints at the expense of longer runtime. On the other hand, choosing runtime optimized trades away some effort on meeting timing for faster compilation. As before, directives are available in the Tools Settings menus and can be used to create implementation run strategies. Subdirective is a new placer option in the advanced flow. This option provides finer-grained control over the different phases of placement: floor planning, global placement, and detailed placement. Unlike directives, you can apply multiple subdirectives at the same time. The dash subdirective option is compatible with other place design options, including dash directive, meaning that you can also combine multiple subdirectives with a directive option for wider exploration. The table here shows the current list of supported subdirectives and their primary purposes. Different subdirectives can be applied to one or more phases of the placement. With advanced flow, these subdirectives unlock more possibilities to explore different combinations of options to increase the likelihood of time enclosure for extremely challenging designs. In the example shown, the subdirective is specified using the familiar Vivado-Tickle list syntax, where the list of subdirectives is contained in curly braces. Each subdirective option is prefixed with the placer phase name and, if applicable, followed by a level value of high, medium, or low. Since the directive option is Explore, the placer initially chooses the Explore setting for each phase of floor plan, G-place, and D-place. Then the subdirective options are applied in addition to the Explore options. For this example, Balanced SLR Medium is used during the floor plan phase, Reduce Congestion High is applied to the G-place phase, and Reduce Pin Density Medium is utilized in D-place phase. Such a combination is only made possible using the advanced flow. Subdirectives unlock more combinations and allow you to explore different options at each placer phase, which covers much more solution space than the original directive options. We mentioned earlier that different subdirectives can be applied to different placer phases. Here we see that the three options on the left, Runtime Optimized, Extra Timing Update, and Extra Timing Opt, apply to each placer phase. On the right, we see which options only apply at certain phases. For example, Balanced SLR can only be applied early during the floor planning phase because it impacts how the design is partitioned. The later phases would be too late. Also, a setting like Reduce Pin Density can only be applied during detailed placement as it involves fine-tuning of cell placement near the final stages. So, it is important to know which subdirectives can be applied at each placer phase. Details can be found in the documentation in the UG 904 Implementation User Guide. Let's look at how directives from prior versions map to their equivalent advanced flow subdirectives. As discussed in the placer directive slide, the familiar Default, Explore, Runtime Optimized, and Quick directives are supported in advanced flow for AMD Versal devices. Many of the prior version directives can be translated to advanced flow using subdirectives and other placer options. A simple example is early block placement, which maps directly to the subdirective gplace.early block placement. A more complex translation is needed for some directives like alt spread logic. Alt spread logic maps to several subdirectives across all placer phases. In some cases, the directive is replaced by an option. Extra net delay high and extra net delay low are each replaced by a new advanced flow place design option with a similar name, net delay weight, which takes the values high and low. A key benefit is that net delay can be used with other directives and subdirectives, unlike the extra net delay directive, uncovering many more possible combinations. Finally, not all directives can be translated to advanced flow equivalent options, as shown in the unsupported table. Here is a recommended approach for the project and non-project flow for the users who prefer scripting. It shows an example recipe to achieve the timing closure with advanced flow placer directives. This recommendation is based on the real customer designs that we ran and found most impactful in terms of design closure. To get an initial time enclosure assessment with the advanced flow implementation, it is suggested to run the following 3 implementation run strategies as part of the first set of runs: Default, Explore, Performance Explore, and Aggressive Explore, Performance Aggressive Explore, which typically achieve the best results. Observe if timing is being met. If the timing is not met, then use the best performing directive from run number 1 and combine with the few key subdirectives as shown. The Advanced Flow Place Design allows both directive and subdirective selection, enabling fine-grained selection of one or more components that make up a directive. The example here shows the multiple subdirectives that can be specified through a non-project flow with the supported phase names. Floor plan for the floor planning phase, G-place for the global placer phase, and D-place for the detailed placer phase. If the second set of runs still has not produced a timing-closed result, take the best performing combination of run number 2 and apply additional subdirectives as shown in run number 3. This methodical approach is more efficient than simply iterating over the entire set of directives and subdirectives, which is extremely costly in terms of compile time and computing resources. It is important to keep in mind that the advanced flow is not a substitute for good design methodology, and it is important to review methodology violations that can lead to timing closure obstacles after every run. Advanced Flow supports implementation run strategies used in AMD Vivado Design Suite projects. There are some implementation guidelines you need to follow. For ease of migration for project flows, most implementation strategies are directly supported in the Advanced Flow with placer directives mapped to their equivalent Advanced Flow directives, subdirectives, and placer options. When an unsupported strategy is encountered, the Vivado tool generates a warning message and continues after selecting the default strategy. User-defined strategies cannot be automatically converted to their Advanced Flow equivalent strategy and instead mapped to the default strategy. New user-defined strategies can be created using new placer subdirectives and options. The strategy editor is fully supported for the Advanced Flow. Now let's talk about what to expect when creating a project or upgrading an existing one to the Advanced Flow. Assuming you reviewed the key changes in the flow and you accept to upgrade to 2024.2, we ask you to archive your project or design first, as this migration is not reversible and the project will reset runs and set options to Advanced Flow, Place, and Route. You can launch the Vivado Design Suite and run the tools using different methods depending on your preference. This slide shows the behavior of 3 compilation flows supported by the Vivado tool and the main points observed when upgrading a design. The boxes on the left and in the middle illustrate the project mode, which supports a GUI mode and a tickle-scripted batch mode. When using the IDE, multiple dialog boxes will show up to configure the options and strategies, and you decide which IP cores to upgrade immediately or later. When using a tickle script for creating or upgrading a project, messages will inform you of the progress and the configured options and strategies. Lastly, you can manage the sources and the design process yourself when using the non-project mode described in the box on the right. During the execution of the non-project script, a few Advanced Flow info messages will show up during the floor planning, placement, and routing processes. As discussed earlier, the AMD Vivado tool uses the Advanced Flow as the default place and route tools for all AMD Versal devices with no license required, so all users can benefit from this enhancement. This means if you are starting fresh with the 2024.2 version, there is virtually no action to be taken and the Advanced Flow is enabled automatically. Once done, the project can only be used with Vivado 2024.2 and later. If you are migrating your project from a previous Vivado generation to Vivado 2024.2, first make sure you back up your older project and only then migrate your Versal Adaptive SoC design to the Advanced Flow. Note that this upgrade requires some extra considerations when compared to a typical project upgrade due to a Vivado version change. This restriction is because the place and route data from pre-2024.2 Vivado versions cannot be opened or reused in the Advanced Flow since the Advanced Flow core placer and router requires a new database structure. As a result, during migration, once you launch Vivado 2024.2 and open the previous version Versal project, you will get a GUI prompt asking you to make a decision to either accept the changes and upgrade to Vivado 2024.2 with Advanced Flow enabled. Note that this migration is not reversible, or cancel and stay in the current Vivado version. Once the project is upgraded, next you should run the report IP status command and upgrade the IPs, not necessarily all together, but step by step as needed. You may need to make minor adjustments here, but the overall IP upgrade flow remains the same as usual. Then, generate the output products, which completes your migration. There are certain features that are not supported in the advanced flow, such as intelligent design runs, incremental implementation flows, and additional power optimization settings. In this session, we have introduced the advanced flow for AMD Versal devices, a new place and route feature set delivered with the AMD Vivado 2024.2 release. The advanced flow features an improved architecture for better compilation of partitions in parallel and new algorithms to reduce routing congestion and better handle complex placement of designs with many global clocks. These improvements shorten the overall design cycle, enabling you to close timing in a shorter time, which enables more turns per day to make you more productive. Finally, if you are migrating from pre-2024.2 Vivado, first make sure you back up your older project and only then migrate your Versal design to the advanced flow. Note that this upgrade requires some additional considerations to be taken into account. Thank you for viewing, and please visit amd.com for more information about the advanced flow.